All right, today we're going to talk about pedigrees. Many of you have probably heard of a pedigree along with dogs or horses and things like that. And so we're going to answer, how do I show inheritance in a family? All right, so what's a pedigree? It's just a graphic representation of inheritance in a family. In other words, it's a family tree and it shows phenotypes or genotypes for a trait. All right, so this is an example of a pedigree. This is the kind of thing that we're going to look at. All right, so how do I draw them? That's pretty important. And how do I interpret it? A square is going to be a male. A circle is going to be a female. If it's not colored in, they don't have the trait. If it is colored in, they do have the trait. And if it's half and half, they are a carrier. Remember, so they're heterozygous. All right, so if we look at this particular pedigree, let's just say this is you, female or male, whichever one you are. This individual, that'd be your mom. This would be your grandpa. That would be your uncle. That would be your aunt. And that would be your cousin. So that's kind of how to read this. So there would be 3 generations within this pedigree. All right, so how do I determine the inheritance pattern? So how do I figure out what kind of trait this is? All right, if it's a dominant trait, they're going to show up in every generation, and there aren't going to be any carriers. You can't be a carrier of a dominant trait. If it's a dominant trait, you either have it or you don't. So let's look at how this pedigree might go. So this individual, let's say that they're heterozygous. Remember, this is a dominant trait, so if you're heterozygous, you got it. And let's say this individual, well, they don't have it, so they have to be homozygous recessive. If we do our Punnett square, we're going to see that 50% of them are going to be dominant, 50% of them are going to be recessive. All right, let's say that this individual who's homozygous recessive marries or has kids with someone who is homozygous dominant. Set up the Punnett square again, all heterozygous, they're all going to have it. So if you notice, they've all shown up in the same, in every generation. All right, remember this girl was a heterozygous individual. If she marries somebody who's homozygous recessive, we're going to get 50-50. So, again, it shows up in every generation, and we don't have any carriers. So if you don't see any carriers and you see it all over the place, dominant trait. Let's say it's a recessive trait, though. These are going to be the ones where you hear people say, oh, that skips a generation. That's because it's a recessive trait. And we're going to see carriers in there. All right, so let's say that, again, since we're talking about a recessive trait, if you have it, you're homozygous recessive. And let's say that this person is homozygous dominant. Set up the Punnett square. All of them are going to be heterozygous. Means they're all going to be carriers. Because remember, heterozygous means carrier. All right. Let's say that this carrier marries another carrier and has kids. Set it up. Now, if you remember way back, this Punnett square is going to end up being a 1 to 2 to 1. So, 25% recessive, 25% heterozygous, so carrier, and 25% no trait. All right, and then finally, let's say that this carrier and this homozygous dominant person have some kids. We're going to end up with 50% no trait, 50% carriers. So again, it has skipped a generation. Nobody in that generation has it. And we have male and female carriers. Now it's important to remember, if it's just a basic recessive trait, males and females can both be carriers. So let's look at a sex-linked trait. And we're going to be talking mostly about sex-linked recessives. Again, it's recessive, so it's going to skip a generation. But, and this is the key difference, we're only going to find female carriers. Because if you remember, You cannot be a male carrier of a sex-linked recessive trait because they only have the one X. And if you look around, you're going to find that mostly people that have it are going to be males. So that's how you kind of decipher whether it's sex-linked recessive or just a regular recessive. So let's look at one. All right, so these are the genotypes of the two parents. You notice that the female is not a carrier, so she's homozygous dominant. The male, with his 1X, has it. We do the Punnett square. We will see that half of the females are going to be carriers, and all the males are going to be unaffected. Let's say that this male, who's unaffected, marries a female carrier. So she's going to be heterozygous. We do the Punnett square. We're going to have a normal female, a carrier female, a normal male, and an affected male. Because remember, the female is the one that determines the trait in the males. All right, now let's say that this carrier female has kids with a affected male. Now remember, we have recessives on both sides. So this is how we can end up with carrier female and an affected female. Normal male, affected male. So again, because it's on both sides, that's the only way we can get that female. But when we look at it, it skips a generation. None of the offspring in this generation have it. We only have female carriers. And of the 5 people that have it, 4 of them are males. So that indicates to us that this is a sex-linked recessive trait. All right, so some key points from pedigrees. Remember, a pedigree shows inheritances in a family. And from a pedigree, you should be able to determine genotypes of people, phenotypes of people, and what type of trait it is by looking at does it skip a generation or not, and what kind of carriers there are. So there you go. That is the basics of pedigrees.